It's my great pleasure to announce this joint event that is jointly organized by our research group, Center for Intelligent Systems and IEEE Estonia. We have two guest lectures today, Dr. Ali Gerish and Murat Gelinch. Sorry for pronouncing wrongly. If it happens, our guests are from Turkey. They're the members of Extended Reality Laboratory from Manisha Chelar Bayar University. So thank you for coming here and giving us agreed to give us this presentation. And I want also to give the floor to Alexei, who is a co-organizer from IEEE side. So just
thanks. So just a few words from my side. So welcome, first of all, welcome everyone. Welcome who is here in this room, and also welcome guys online. I'm very happy that you joined us. So just to clarify, this event is jointly co-organized by Center for Intelligent Systems and IEEE Estonia Young Professionals Affinity Group. So if you want to learn more about our activities, please visit IEEE.ee. There up front, you will see like all the events that we organize. Maybe you will be interested in some others as well, because we're quite active. Almost every week we have some new meeting, some new interesting opportunity to meet interesting people. So in any case, thank you for coming. And now I think we can start the main event. So I will give the floor to you guys. Thank you.
Okay, so hello again. Good morning, everyone.
One second.
Okay.
You can also share the screen.
Yeah, of course.
Yes, it's working.
Okay, just all of.
Yes.
Okay. Thank you. And
Great.
okay,
You're all set.
okay. So good morning again. Firstly, I want to thank you, Alexei and Eduard, for the invited here for us. And we talk about today the rise of intelligent virtual worlds, because I think, working the same research areas for you and for your research groups. Before the presentation, just I will talk about a little to our little story. I am Ali Gerish. I'm a PhD in actually computer education and instructional technologies. And Murat is also a PhD. He's working on business intelligence systems, actually. We are 4 people in our laboratory right now. It's a very little short story, actually, because we met the last year, beginning of the 22. So 2 of us actually working on 3D virtual worlds, 2 of us working on intelligence systems, and we combine these forces to create new virtual worlds or something intelligent virtual worlds. So also we established an extended reality laboratory. Actually beginning of this year, end of the last year. So we are focusing actually 3D virtual worlds, virtual reality. Also, we have some extended reality works right now. Some of us are working on these technologies, and also some of us working on intelligent system and machine learning projects. So today, this is our outline. We talk about a little VR XR technologies. Also, we talk about AI VI systems, and we actually created the intelligent virtual world for our university, 3D VR campus. We talk about building the MetaCBU for 3D worlds. Also, we talk about these systems background, the data sets or some predictive models and some processing data in virtual system. And also we talk about a little new AI tools. It's very new and fresh topic for us. Also, lastly, we talk about a little considerations about the VR and AI systems, and we finalized our presentation. This is chapter 1. It's a very little story actually, because all of us, I think, we know the virtual reality, what's the virtual reality and what's the extended reality, but it's just the introduction for us. Virtual reality refers to computer simulated reality that enables users to living a real life situations in virtual worlds. So this is very useful for actually learners and some of us, because we generally don't see everything in real life because some dangers maybe or some physical problems for us. So we using virtual reality systems for these situations, and last 10 years actually a lot of new head-mounted displays released our lives. So we talk about a little this new generation head-mounted displays. Also, we have a lot of now 3D virtual worlds, especially for 3 years or 2 years. Why do we prefer VR actually? Because literature says us VR supports peer cooperative learning. VR develops the ability to learners to solve problems, or increasing student motivation, or offering a high level interaction for us. This is VR's positive effects for learners or users. So how can we do it? Like that, because it's first VR's virtual reality system in 1962. But today's a lot of different head-mounted displays, Oculus and I think HTC, the most popular virtual glasses in world. But these two is very new. They are released at the beginning of this year. Oculus Pro and HTC XR Elite. We have one of them. It's more good, I think. So what about the virtual worlds? Because we have a lot of head-mounted displays, but there is a lot of virtual worlds or something else. This is Ancestor, I think. Second Life is more old version of the virtual worlds, and it's changed the Sansar 2017 or 2018 because they changed the concept, and we can use the Second Life platforms in VR system in Sansar. So I applied them the beginning of the beta version of Sansar, and I joined the developer for Sansar. It's more useful for developers want to develop as something main and basic systems, but for the more complex systems, Sansar is not effective because we don't control everything in this platform. And I think we know, all of us, we know, 2 years ago, Meta released their, metaverse system, the old world, and Virtualverse increased it very, fastly. A lot of Virtualverse is the internet. One of them is Horizon, the Meta's Virtualverse. VR chat, actually, maybe you are using the VR chat, Roblox, and hubs from the Mozilla. So we have a lot of actually Virtualverse in the internet, but we have some problems in this verse because all of the platforms, focusing social interactions and social platforms like Facebook or Twitter, something else, because we just contacting the other people and we are sharing our ideas, or we are just chatting them. But we don't have any experience-based interactions in these systems. We don't have any educational contents, or we don't control the auditable system in these platforms. Also, we don't collect the user data, but user data is very important for us, especially educationals and lecturers, because we have to control our research to see the successful or positive or negative effects on the learners. So, but of course, there are some 3D verse or some virtual reality platforms or virtual reality environments created the educational purposes. One of them is heart evaluation. It's a very good example, I think. Autonomy, where I think you can know that because it's very popular for the medicine systems, and also CalcFlow calculate some visual part of the physical elements, and I think this is our focuses. VR robotics simulator. We can control some VR robots in this virtual world. So in this stage, actually 4 or 5 years ago, in my PhD thesis, I think about how can I develop a virtual reality system, because in our university, we give classes for the learners using IoT circuits and coding these IoT projects. But we saw something problems in this situation, because learners generally doesn't have any motivation for these systems, because they are seeing a lot of problems creating some circuits or programming these projects. So I decided to create a 3D virtual reality system for making some IoT projects and programming these projects with block-based programming, because I wanted that new students doesn't lose motivation for the simple problems. So I created a 3D virtual world. Actually, we are using this system in actually for HTC, but now I have to change the system for actually also Oculus. I created some models from the processors and circuit elements. Also, I added interaction, all of the objects as a real life. In this system, we control the physical sources and build some, projects. I give an opportunity to do block-based coding. This is visual features actually. Also, I wanted to learn how the students gained the process this education and how they how much they learned these projects in real life. So I added some background features. I collected the user session durations, time spent on the platform. Also, I collected time spent in different areas on the platform, completion of tasks. Also, I collected participant scores every task, and I collected their preferred training materials for learning something in this platform. Also, after the background features, I gave a little real project job for creating new IoT project in real life, because actually they didn't know about anything in IoT. Firstly, they learned IoT in this platform, and I gave it a new task for in real life, and I wanted them to create new, project in circuit elements and also programming in block based. So they actually achieved 80% of is very successful, I think. So it give us a little good opportunity for the beginners, I think, learning the IoT. And after this all processes, we met our friends Murat, Barış, and Orkun. Also, they finished their PhD thesis nearly to me, and we think that we can collaborate our forces creating new materials, and we started a new project. But this situation, I think Murat talked about their expertise and his research focuses. Also, after that, we combined the new project for us.
Okay, good morning, everyone. Before I start, let me tell you something about myself. My name is Murat Kılınç. I'm a lecturer at Computer Research and Application Center of Manisa Cerrahpaşa University. My research areas are business intelligence, business analytics, machine learning, and web development. I've also been working on virtual reality. We are also a member of Manisa Cerrahpaşa University XR Lab. And also I'm developing on create a dashboard with VR data from virtual reality labs. Okay, I use the screen when I present. In chapter 2, I will talk about the combination of business intelligence and machine learning. Okay, I also use this combination in my PhD thesis when developing CF test application. Actually, business intelligence and machine learning can provide very high performance solutions for different problems in different files. In the literature, the combination of business intelligence and machine learning provides good results for users at strategic and operational levels, especially for decision support systems. By the way, CF test application is a decision support system to increase the success of crowdfunding projects. Due to the high success rate and decision support, we plan to use this combination with VR data in MetaCBU. Okay. And so let's take a brief look at CF test, crowdfunding test, and AI and BI based application developed using crowdfunding data. AI and BI based CF test decision support system has been developed to increase the success and funding capacity of crowdfunding projects. Within the system, user can test their own projects and get recommendations for project success. Actually, CF test consists of two main parts. First part is AI tools. Second part is BI tools. AI tools consists of two main parts. These parts are crowdfunding project success predict tool and crowdfunding projects text analysis tool. And BI tools consist of data visualization, instant reporting, recommendation systems, and StarNet and OLAP queries. Okay, now I would like to CFTest web interface and the AI and BI tools deployed in it. When we look at the interface of the application, you can see a list of project offers users in the section. And this screen, you see the profile page where the user can see all the statistics on the profile. And one of the other tools in CFTest is the system recommendation section, where each user can get a system recommendation by entering the features of the crowdfunding projects in text boxes. In this section, you can see the CFTest success prediction tool created by machine learning algorithms. These algorithms are gradient boosting, logistic regression, support vector machine, random forest, and decision support. Users can get predictions about whether their projects will be successful or not according to the features they enter. Okay, finally, in chapter 2, I would like to show you CFTest text classification tool. A data-driven approach was used to classification crowdfunding project text. I used a lot of algorithms when text classification tool. These algorithms are multinomial knee bias, logistic regression, and support vector machine algorithms. Also, the number of the data expected to increase in order to train the LSTM model, which gives better results with longer sentences. The success rate of the model created in this form is 74%. Okay, the combination of AI and BI is of a great importance in system development process and ensures that development process are data-driven. We think that the combination of AI and BI will provide good inferences in VR data. In this context, MetaCBU studies, which is a VR XR environment, continue. And in this section, Ali will give a detailed information about MetaCBU. Okay.
Okay, again. So, thank you. It's okay.
Commander.
Yes.
Okay. The Holger firstly. I didn't rest it. So this is chapter 3, our main project developing right now in our university. MetaCBU, our university's immersive experience learning environment actually. It's VR based and we are adding some XR technologies next feature. So what's the MetaCBU? It's an immersive learning environment I told, but also it can be accessed through the with desktop enabled. You can control the whole system on your desktop PC, or you can control the whole system in virtual reality systems, Oculus and also HTC. We have right now Oculus and HTC that mounted displays, so we are developing in this VR glasses. Also, we are adding a lot of things in this system actually, because university is a very big environment. We have a lot of different departments. Our university also you have, I know, but all the departments asking their topics or their lessons in processing this platform. So we have added some of the features right now. Some of them about the health systems, engineering, physics, and chemistry. Also, we have added some social areas for learners and for students. Also, we have added this platform some universities, private things, also introduction steps. I told virtual reality we are using right now Steam and Oculus in this platform. So what's the general characteristics of MetaCBU? We have two running systems in this platform. It's VR-based and desktop-enabled. We can use the system in multiplayer. Okay. Also, we have voice-based chat in this platform, and of course we have text-based chats. But right now, text-based chats we didn't try because we are focusing in voice-based chats right now. It's more important thing, I think, the text-based chat. So after me, Murat talk again about the intelligent systems, the background of the VR platform. We have using some AI-powered systems in this platform. Also, we have using machine learning algorithms and some predictive models. And Murat and Orkun developing a dynamic web portal for the all data usage and visualization for reporting and query systems. So this is general, and I can talk about the technical structure of the virtual part of the this platform. We are using Unity game engine, and we are using Photon servers, Photon and Photon Voice. Actually, two different servers we are using in this platform. For the developing VR interactions, we are using Oculus, SteamVR, OpenVR, and Unity XR and VRTK packages in Unity. Also, we are using Unity interaction systems, SteamVR's, TLIans in their packages for controlling some different part of the interactions. For the avatar system, we are using full body avatars right now with Ready Player Me. I think you know the Ready Player Me because it's Estonian company actually. We met the last year there, and we are using right now the Ready Player Me avatars. So for the control of the avatars, we are using Final IP and Unity body system packages. Of course, we are developing a virtual reality platform, and we have to develop 3D models for this system because it's very complicated platform. For this, we are using Blender, SolidWorks, and 3D SMX programs. Of course, we are using some graphic tools. Illustrator is the basic part of the system. And this is general structure, actually, general scene for our university platform. In this scene right now, we have rectorate building, international office, academic departments, and academic centers. Also, we have a big convention center in this platform, classrooms, a little social areas, sport course, and of course, we have a library in this system. It's actual library, and we have a clinic, but it's actually developing right now because our medicine lecturers is asking every day different features for these rooms. So I talk about a little our main part of the platform. This is the library. We can control the book like a real life, and we are reading their PDFs document in our library. We think that actually we will do it. We will add all PDF book database, and we downloaded the PDF books choosing students options. If you go to the library, you can choose a PDF book and reading this book on the platform. I think it's more effective because if you check all library and PDF books in VR, we can control everything, and we are reading as a real life. So I think this part is very important for us. This is our clinic. I said it's changing every day because these are very specific objects in here. So we added some organs and some health systems right now. We are interaction with all things and all surgeon tools in right now. So in next feature, we add some different features to this part of the platform. This is our social areas. One of them is basketball court. You play the basketball in this court. Also, we have a chessboard on the floor. We are controlling the chess, but Alexei, I think last days, so we don't see each other. Maybe I can control the other chess. You know, is in here. It's changing the head, but I think we consider it. So we also add table tennis right now. We are trying it more effective. You know, it's just developing process, but we will add this also our platforms. And this is our physical interactions demo, I think, because we control everything actually. Just we are adding the part of these interactions for using you know, special features. We can see some of this here, grabbing, handling, or you know, putting like that, adding the other objects to each other. So also we control the gravity level of the objects in this system, or we can organize every object like a real life or like another system, maybe move. So I think I lastly talk about our server structure, because I said we have two server right now. One of them is the main server for login and registry for users, and controlling the all multiplayer system in this Photon server, because all users log in the main Photon server, and also we add some objects, for example, chess systems in this Photon server actually, and we are seeing like a real life in with this Photon server. Also, we have another server for the voice chat. This server just using the voice systems. When we talk in the VR platform, all voices going to second server, and we are getting in with this server. So all users and all tools logging the first server, and also logging the second server, and we are using all these data with same time. So this is the last verse for the chapter 3, and chapter 4, Murat is again here.
Okay. I would like to tell you about the application called MetaPortal, which is the development process. In chapter 4, I will talk about and I will explain MetaPortal process. We are conducting study together with XR Lab members. I'm going to focus on 3 main parts in chapter 4. Respectively, first of all, I will talk about the data processing methodology, architecture, and technical structure. Second of all, I will inform how we proposed a solution to user classification in MetaCBU with machine learning and business intelligence techniques. Finally, I will share with you the results that are likely to be obtained with the MetaPortal application that we will develop with these techniques. These techniques are machine learning and business intelligence. Okay. Let's look at the methodology we used to develop MetaPortal application. In order to develop MetaPortal application, the data mining project cycle, abbreviated as CRISP-DM methodology, was used, and the 6 stages in the cycle were carried out in order. The cycle consists of business understanding, data preparation, modeling, evaluation, and lastly, deployment and control. Thanks to this feature on the model, which is frequently used in data science projects, it's possible to go to previous step and make changes. Okay. So let's move on to MetaPortal architecture. Actually, MetaPortal, within the scope of system architecture, the MetaPortal system consists of the 3 main parts. First part is ETL process, extract, transform, load process, abbreviated as ETL, and AI and BI tools and query process. Actually consists of business intelligence and machine learning consists of MetaPortal architecture. You can see the software libraries and structures used in technical structure in this section. The structures to be used in data collection, data preprocessing, feature selection, machine learning and deep learning, and web application. We used to Python programming language for data collection, data preprocessing, feature selection, machine learning and deep learning, but we used to develop for develop web application. We used to PHP, Python, and JavaScript language. Okay. After the technical structure, the virtual preprocessing welcome us. 4 different processes were applied in data process related to MetaPortal. Firstly, the data collect welcome us. Data from the MetaCBU virtual environment was transferred to MetaPortal database using triggers and data scraping techniques. Secondly, the data preprocessing welcome us. Normalization, scaling, and missing data completion process were evaluated within the scope of this data preprocessing. And thirdly, data cleaning, the process that would prevent data analysis were cleaned from dataset. By the way, first 3 section is done, but feature selection is not done. Feature selection will be used in the user type classification problem and will be applied in the MetaPortal AI tool development process together with filtering and wrapper methods. Actually, in wrapper methods, we will use the recursive feature elimination with cross-validation method. So now we are come to business intelligence section. Then let's detail the business intelligence part based on MetaPortal architecture. Within the scope of business intelligence, the data set obtained by data scraping was made ready for analysis after entering the ETL extract, transform, load process. The data in the data warehouse was then used for data visualization, analysis and reporting, and lastly, data mining. Also, with the integration of data marts, each user type can only see their own analysis in MetaPortal interface. Okay, I have explained how we use business intelligence in MetaPortal application. Now, I would like to discuss OLAP queries for virtual data. Actually, online analytical processing is abbreviated as OLAP, is a business intelligence component that enables large analytical queries using the data warehouse infrastructure to quickly return results. On the other hand, OLAP cubes are operationally consist of 5 main parts: roll-up, drill down, slice and dice, and lastly, pivot. You can see a sample OLAP query obtained data with time, location, and interaction dimension. The application we have developed with this OLAP architecture will transfer it to CFTest users with dynamic HR graphics on the dashboard. Then in the next section, I will show you StarNet query. I will explain how StarNet queries will transfer to application, MetaPortal application we are developing. In the graphic on the right, you can see a sample StarNet query created with features obtained by feature selection. You see the social users pattern with red lines, and you see the Explorer user pattern created with yellow line. In this way, MetaCBU developers will classify users through the MetaPortal application and make improvements specific to this class. These classes are social class and Explorer class. Okay, now let's look at the algorithm and evaluation metrics used in our study. The learning process proceeds as follows, as can be seen on the flow on the left. Model training will be performed with the algorithms used. All features in dataset, selecting the best subset, application of learning algorithms, and lastly, performance monitoring. We will use these algorithms in our study. These algorithms are random forest, k-nearest link board, support vector machine, logistic regression, and gradient boosting. And model evaluation metrics will be applied with these techniques. These techniques are FPIR score, precision, recall, area under cover score, kappa score, and lastly, RAG curve. So let's move on to MetaPortal application user interface. This is our MetaPortal dashboard demo. Looking at the web application, many charts and lists will created with the data of MetaCBU VR data. Also, as can be seen on the sidebar, many pages such as data management, data analytics, and impact research, reporting. By the way, data management consists of a lot of pages. For example, interaction analysis, task analysis, process analysis, user analysis. And after the web application UI, the classification UI welcome us. A prediction tool will be developed to solve the user classification problem with feature selection in MetaPortal. Since the evaluation metrics are also presented with graphics in Designer tool, a comprehensive evaluation opportunity is offered. According to classification results in MetaPortal, MetaCBU users will be classified according to various characteristics, and a development structure will be put forward accordingly. In the classification tool, MetaCBU users, MetaCBU developers will be able to classify users and compile results from different algorithms. Okay, finally, let's look at the conclusion and last words about to in chapter 4. In order to better understand the data in virtual environments and make improvements based on data, there is a need for decision support systems that offer suggestions for improvement. Within the scope of the system developed based on VR data analysis, the model that will contribute to literature will continue to be implemented with MetaPortal. In future studies, maybe better learning models can be created by adding more user data to the system. Also, more comprehensive results maybe can be obtained with business intelligence analysis to be created with increasing number of VR data. That's the end of chapter 4. Ali will give detailed information another chapter. Okay.
It's good.
Yes.
Okay. So, we talked about our MetaCBU project and the background of the project, MetaPortal. So, in this process, we saw something new AI tools for our systems. Also, we saw a lot of new AI tools for VR XR platforms. I talked about little bit these AI tools because we want to use these AI tools our projects. Maybe also we want to use it, and last November after the ChatGPT 3. A lot of AI tools released on the internet. Just last month in April, over 1,000 of the new AI tools released all world. So, of course, new AI tools for released 3D systems. one of them is new prompt system, ChatGPT based. You can use this AI tool in the Unity and just giving a new prompts. You can create some 3D models in Unity or also new scenes. The other one is Spline AI. It's a new generation AI 3D engine, I think. So you are using just prompts like the ChatGPT. You can create new scenes. This Spline AI tool. It's more basic, I think, because all models and all 3D objects like a cartoon graphics. But in the beginning of the learning these systems is maybe more effective for the beginning of the learners. The other one is Blender Copilot. Actually, it's based on ChatGPT. You can use the prompts for creating 3D models in the Blender. We are using the Blender for creating and developing 3D models for our projects. I didn't try it right now, but I will try it because it seems very useful. But I don't know how much is good or more it's effective or not. I will try it. Maybe you also you want to try it. The other one is our turn. Is very new, and I gave a mission to our friends for this actually this AI tool. He right now trying this AI tool for creating a new avatar because with this avatar you can create own avatar, just a photo in this real system, and avatar has a SDK for Unity and integrating all character in Unity like a Ready Play Me avatars, full body avatars. So I think it's seeing more useful, but we will try it. I don't know how it's effective. The last one is Skybox. Maybe you saw it because it's very actually funny thing, I think, because you just giving a prompt for I right here. It's a sunny day, and it's creating a lot of Skybox models for you. Actually, it's good, but also it's funny because creating a lot of Skybox for you, your thinkings and your feelings just right here, and see a lot of different words for you. It is 5 AI tools for creating new VR or VR systems. We want to add these AI tools for show you to see another new generation systems for VR systems. And actually, we talk about some considerations in this whole presentation, because a lot of problematic situations happening in these VR systems or AI systems, because a lot of considerations in these systems. These are in the literature, all researchers say that their main problematic situations in real life with these VR systems. So first off is actually low ethical considerations is meaning problematic considerations actually. In the second part of the considerations, I can talk about the high ethical considerations. Their meaning is actually positive considerations for creating some systems. The low ethical considerations is just meaning problematic situations, harassment, bullying, assaults, hate speech in virtual reality or virtual systems, negative transfers, harmful psychological and physical effects, torture, addiction, also data misuse, privacy loss, or decision, hiding through intent, unanticipated physical parts of the virtual reality systems. These are very problematic situations in we are seeing using the virtual reality systems or using virtual worlds to each others. So this one is high ethical considerations. Generally, we can actually see all ethical considerations in this part. One of them is creating community mentorships in these platforms. We give positive psychological effects or behavior change processes in this platform is also positives. We can create realistic environments for psychological damages. Also, we can create some realistic environments for gaining some behavioral changes for learners. Also, we can control all privacy and biometric data of our systems. We can give a safety and minimizing risk our systems. This is positive part of these considerations. So why I talk about these considerations? Because creating MetaCBU project, we are carrying these considerations because very important for us also, I think, learners or students or lecturers. How? Firstly, for in virtual realities platforms, you can interact with other people's like a real life chat or something, physical interactions. But also you can fight them each others, or you can put a ball with the other one's heads. Is problematic situation. We can control users' interactions in with each others. We don't allow their interactions in real life with full body avatars. Okay, if you want to fight each others, you don't do it because we control it. So other one is the contents. If you want, you can put the all problematic contents there in your virtual reality systems. But in this platform, we control the contents and books also with our teams for some don't see problematic situations. Also, we used all data in secure servers or university servers, and we don't share any data or our data sets with third parties. Just we are using the all datas. Also, we are adding some educational content for behavior development, positive effects of the learners. Also, we are using realistic and authentic design because in these systems, if you want to use these systems, I think you want to see realistic graphics and realistic models, and we are using all these design systems. After that, we are giving a content to support field navigation and also developing individual learning. So we have a cookie policy for Meta Portal. And lastly, we are developing a virtual reality system, but Also, we are trying every day these systems. For this, we create a laboratory for virtual reality system, and it's very safety. We are using cable system for the up the room. Also, we added a lot of line and safety boards of our laboratory. These are MetaCBU considerations, creating some safe, positive, and developing behavioral learning for our students. So I talk last words for me. This is all-in-one situation, all structure of the our platforms. Just abstract for controlling all things in just one presentation. And these are references for this presentation. If you want to control the literature, you can use it. So thank you for participation and interest. You listen us and you give a chance for the presentation of our project and our task. So if you have any question, of course, we can answer it. Thank you.
I wanted to ask, in the first application that you showed, where the students are doing this breadboard design and using the blocks for programming, was this part of a course that students were being taught, or?
Okay, it's not a part of a course, because I developed this platform just beginning of the learners. They are dumb learners actually. They don't know anything about IoT. They are amateurs, but I created the system for beginning of the new and basic projects of the IoT. Firstly, they learned what's the IoT in this platform. They learned every because processors and circuit elements with videos, voices, and they saw all elements in 3D models. And also they learned what's the block programming, what's the by the way, all learning process, in you learn everything in virtual reality system, not the real life. I actually put them to virtual reality system, and they learned everything in that platform. After the learning process, they saw 3 projects, actually basic, middle, and some more expertise. And they do it step by step. Actually, after this process, we finished the virtual reality process of the learning. Lastly, I give a real life project in our laboratory, and they created a new project with different circuit elements. So if you want, I can share with this platform with you. I can send an email to download the platform, and you can check it. And also, I think maybe you can return to me, give feedback, because this platform also another project's main focus right now, because I will upgrade it for Oculus and other systems. Also, we will add some new educational materials this platform. So maybe next week, in the next, we can also add this platform to our other university project. So if you give a feedback to us about this project, I will be happy actually.
Thank you.
Thank you.
Maybe you also have some questions. Okay, I can take one. Okay, so you have previously shown an example of using AI with some 3D modeling software and things like this, right? So how does this fit into your workflow? Just how does this fit into your workflow? What does it give you in terms of your framework or your solution?
Actually, we developing this platform is two different parts. One part is just virtual reality. Developing the virtual reality system is the first part of the workflow, and the second part of the workflow is developing AI and BI systems. I know all thing about the workflow one because it's under my control, but I don't know anything about the Murat's parts of the system. I just saying that this is our data. I want to learn this users what happened in this platform, and he and Orkun adding some codes. I don't know, adding some new features the portal. So maybe Murat talk about the other part of the system.
If you want, I will explain workflow, but I will give help translation Turkish and English. Bu şekilde yapalım. Buradaki şeyleri biz AI verilerini veri yakalama teknikleriyle elde edeceğiz. Ondan sonra bizim içeriye aktaracağız.
Okay. He said actually, in the VR platform, users doing something different, some navigations or some interactions. Firstly, we cache the all data with triggers in the virtual reality system. We adding a lot of trigger system actually, our models or interaction systems, our buildings, or whatever you want. We are adding some triggers, and we catch all triggers, and we sending to all data to a database, data warehouse. And after that, they are catching all data and adding their data warehouse, and they are processing all data in this another platform, actually MetaPortal.
For the model creation, firstly we use data for data. We use feature selection. Feature selection is most important part is for our study, and after we create a model.
Okay, that is clear, but I was more referring to this ChatGPT integration into some of the applications there, like you can in Unity or in Blender, you can kind of describe what you want to see, and then it creates these shapes. So I was thinking how you integrate something like this.
Okay.
Do you use it?
Okay, I get it. I think we will try some prompts for Unity or Blenders, with Copilot, but I'm not sure if I'm not sure that we have to add all prompts or prompts systems or unities, because I don't know how they adding the actually background of the this system or Unity. We are using Unity, and Unity is not a very good game engine. It's good, okay, but it's unpredictable. Changing everything in every upgrading version. If I add the Unity prompt systems or, for example, version 2021, but upgrade the 2022, I don't know if it's working or not. So I think we can use these prompt systems in just learning some new things, or we can use these prompt systems for beginners. You think that you are a student and you want to use Unity, but you don't know anything about Unity. But first of the beginning the Unity, you can use learn how is going on everything in Unity. You can use some prompts maybe. I don't know.
Okay. I cannot let go of this question. So how complicated can it go? Like, what can you expect with prompting in that situation? Like, can it create some complex logic already, or, I mean, for Unity specifically, or what is your experience? How complex can you get?
Actually, right now, I can say that I tried the just easy things with these prompts. I didn't complex prompts. I didn't give a complex prompt to Unity based Unity ChatGPT attempts, and I don't have any chance to give a real answer to your question, because I said it's we tried it, but it's more basic things. But next weeks or next months, I will try it more complex prompts in Unity, and we can see how is it going on.
Okay, now the reason why I took so long with this question is because usually I see, like, even with the Blender plugin, for example, usually people are like, okay, give me a random number of randomly colored cubes and place them like random locations. Okay, that's great, but how can it be like used with some specific tasks?
Yeah, you are right.
Can it actually draw some complex mesh that will also be editable eventually, because that's the workflow in Blender. So just because of that, I was curious if you have any experience.
Yes, also I'm curious because 3D models very important for our projects, because actually your projects effectively is based on quality of the 3D models. If you don't use good models in your systems, it's working very slowly and decreasing the FPS and increasing the latency actually, and it's very problematic for the users. So I think right now the prompts, creating some models, maybe creating some materials or creating some texture for these models, but I don't think that the prompts actually maybe decreasing the polygons of the polygons counts of the models. So maybe next future they are at these features.
Yes,
I hope
it's interesting. It's an interesting technology. It's interesting to see where it goes. But okay, thank you.
Thank you.
I have a question maybe for Murat. You gave an example of how you use AI in your system by classifying the user type, and there was a social user explorer. Yes. Okay. And usually in the beginning you need some labeled data to train the system. Is this correct? How do you label whether the user is social or explorer?
And I use the sen söylemiştim.
Actually, in the literature, gamers have different features using the game platforms. Some of them loving the navigating everywhere and
Yeah, if you can go back to the slide.
Okay,
you
okay.
had this
Drawing
drawing.
or standard query, which one?
Find the slide, I think. You have this drawing.
This
you
one,
use voice
or-
chat or next one.
Probably you say
This one,
standard.
yes. This one.
Okay, okay. We use these features, communication type, object type, number of interactions, but this is demo. Just demo. After the feature selection methodology, these features are changed. These features will be changed. And this standard query is creating, is new creating for all users. And maybe this class maybe increase in feature. We just use this class, social and explorer class. Maybe in future this class are increased.
Actually, a lot of gamer types in literature, you know. These are just two of them, and it's for the demo. So in the next future, actually, when we use this platform with all students, because we have, I think, 60,000 students, if I don't know roughly, but it's mean 60,000 students. So we gain a lot of data in the system, and we will use all the data for creating some predictive models, and we give a label social and explorer class to our students in the next future.
My question still, maybe an answer is that how do you label the data?
Are you using basically clustering or classification? So because
Yeah.
with clustering, this is unsupervised, and then you do not to label anything. Yes.
Tamam. Veri etiketlemeyi manuel olarak yapacağız. Model geliştirme ona uygun bir şekilde olacak. Ondan sonrasında zaten tahminleme süreçleri olacak.
Okay.
Yani biz etiketlemeyi manuel olarak
We will do with label system with manually.
Manual
Okay.
label.
Our expert users add some label for manually, and after that,
daha sonrasında model geliştirme süreci.
okay, we develop a new model.
Understood. Thank you.
But basically, I have a question from the same field. So, why do you need this basically classification of the users? So, what is the final purpose of that?
Okay. Şeyi söyleyebilir misin? Kullanıcıları sınıflandırma sonucunda geliştiriciler bir karar desteğine sahip olacak ve biz buna uygun geliştirmeler yapacağız.
Okay, the purpose is that we collect all data about the users, actual students, and we learn about their habits in this and behaviors in this virtual system. And after that, after learn all things about the students, we will develop new learning materials for their behaviors and their individual features. For example, for the beginning, for the login the system, if you are a social learners, we actually we will add new materials and teaching materials for social learners. The main purpose of this classification, we want to give individual learning materials for all students.
Şeyi de söyleyebiliriz bu arada. Kullanıcıların bizim MetaCBU içerisinde en çok tercih ettiği alanları gösterecek bir ısı haritası da olacak bu verilere dayanarak.
Also, we will add a heat map for our platform. students they prefer which part of the platform. They are preferring the social areas, or they are preferring the classes, or they are preferring the just chat rooms maybe. We are adding a heat map for this, seeing this visualization. We will add another visual for the next picture.
I have final question.
Okay, no problem.
Sorry. You mentioned you collect a lot of data, but you said you're using Photon for multiplayer, right? Unity.
Yeah.
And then, but you're collecting a lot of data also at the same time from the VR environment. You said you're sending the data to a database.
Not database, data warehouse.
Data warehouse.
Data warehouse.
Okay. Can you explain a little bit how is the structure of the server? So where is the data being stored?
Okay.
I mean, and how often are you storing the data? Are you doing it every frame? Do you log the, let's say, all the coordinates of the VR headset and controller, or just triggers?
Actually, right now, I said we have two servers. It's not important because it's just voice-based, just a voice system. But the main server is all things happens in this server. We are registering, logging, and we are adding 3D object triggers in this server. But we don't collect in the server actually. It's just seeing in multiplayer for all users. If you want to use this, tool in our virtual system, if you handle it, if you grab this object, a trigger, sending a just binary code to our data warehouse. It's actually another server, right?
Yeah.
Actually, we don't use this server for the using collecting the data. So if you put again in here, sending another data to our data warehouse, and we collect all users' interaction like that.
Okay, so each client sends the data directly to the warehouse, right? So each has you don't have a main server that controls and validates. So maybe if somebody, I'm just thinking, maybe somebody has a device at home, they can fetch the data. They can just send random.
Okay, I understand it. But if you are at home, you can. If you want to use this platform, you must log in. When you log in, you have a user ID actually, and it's unique.
We use LDAP and SSO sources in our university. When users log in the system, actually user log into all systems.
So you connect the login system to the university.
Yeah. Okay. We use LDAP or SSO service.
I'm not aware.
Single sign-on.
Okay. Thank you.
So, okay.
No more.
I think it's finished. Thank you again.
Thank you.